Hello again. Here I have an Amiga 500 and this is a video about GGLabs DiagROM, which I've ordered. We're going to test it on this Amiga 500 motherboard. So here it is, available on eBay from GGLabs. So I ordered this, told the seller, GGLabs, that I needed it for release 5. He mentioned that in the listing I needed to let him know if it was for an older 2000 or 500 motherboard, because this PCB needs to be modified. A couple of traces need to be cut, a resistor needs to be added, and another jumper needs to be made. So two things are cut, two things are added. And I believe, doing research, I found out that that is the classic oops problem that the older motherboards have, where you have to connect pin 1 and 31 and cut one of them or lift it off or whatever. That has to be applied to this as well, because this is designed out of the box, apparently, to work on a newer 500 or 1000 or 2000 motherboard. Frankly, I want to use this for both Amiga 500 older releases and newer releases in 2000s as well. So I am going to, in this video, attempt to design a switch mechanism for it so that I can switch it back and forth. It's on a circuit board, so I should be able to mount something on this circuit board, you know, maybe with some hot melt glue or something like that. I don't know that I'd be able to get the case on once I'm done, but that's not important anyway, because I never have the case on when I'm diagnosing something anyway. Take the Amiga out. I mean, at the very least, you'll have at least the 500 in its bottom case. So here I have my Amiga 500, or actually my cousin's Amiga 500 release 5, and here I have like almost a pristine release 6 Amiga 500 that I picked up at some point, and I think it was the first one I got, and I've hung on to it because I really like it. I tried to put this into the release 5 and nothing worked, and now I'm going to plug it into the release 6 and we'll just verify that it works before I start modifying it. So this is the menu that most people have seen if they ever looked at it or whatever, or saw pictures of it. Cool. So I'm going to use this ROM to test faulty chips, and I actually have a collection of faulty chips so that I can use this to test and compare them, you know, and see. But first we're gonna take this DiagROM and modify it. And so let me just back over here. I have a few notes I've been printing out just to get myself started here. On GGLabs website, you can get the schematic for the board. It's one of those types of schematics that some people, I guess, refer to as a block diagram, because it doesn't give you real specific information or locations in the layout. It's got stuff like this, where this is on the board, but it's just separated from the rest of the, you know, schematic or whatever it is. So that's like, oh, where is that? You know, how is that connected? So you have to go onto the board and say, oh, that's connected to here, byte. An A17, there's an A17 pin coming off this. It's right there, in fact. So this is the jumper between 31 and 1 right here that is not connected right now, but it shows that you put a 0 ohm resistor, which is the same as just a blob of solder or straight short or whatever. So anyway, I'm going to take all this information and put it together in something that I can use as a guide to modify this chip so that I can create a couple of, I need to use a double pole switch, I guess, you know, to make it so that I can easily just put this into another mode to be used on different versions of Amiga motherboards. So the reason why I couldn't finish this diagram is because I don't know, for example, what side of R6 goes to pin 31 and which side goes to pin 1. I actually don't know, and I need to find that out if I want to make, if I want to minimize the amount of connections I'm having to solder or whatever, because sure, I could put like 3-4 switches. I mean, it has 2 that I'm supposed to open and 2 that I'm supposed to short, or one of them that I'm shorting is actually has a resistor supposedly on it. You know, so I'm closing 2 connections and opening 2 connections, but the thing is I'm doing on 2 of those. It can be solved with a simple 2-position, you know, toggle switch. In order to get started with that, I actually need to find out which side of these chips go where, and maybe even just confirm. Yeah, so I definitely need to confirm. Sorry, I'm thinking about something else here. I need to confirm what side is going to where now. Let's zoom in. So this one here, you know, R7, I guess it is. You know what? It's not going to do me any good though, unless I have an open on that one. Right now that one is closed. But I can pretty much, I mean, I don't know which one of these it is. I'll have to cut that trace first and then figure it out. But this one is open already, R6. So I want to find out if that's running over to pin 1. So pin 1 is over here. Oh, I want to find which side of it goes to pin 1. So pin 1 is way over here by R7 on the other side. And I'm going to go here and see if I can get some continuity on it. There it is. Okay, alright, so that's going to be one of our switches. So I'm correct right here, and I'm correct with my assessment here. And that means this other side goes to pin 31, as well as this other side, this side of R4. And that shows it in the schematic. So there's probably just a shorting between these 2, and then just one of these runs over to 31. So let's just confirm that. I've got that right there. I'm on R4, and what do? We go down one right here. Okay, I have cut the trace on R7. So, yeah. So, yeah. Nope. There we go. Okay, so the top one is pin 1, you know, as I expected. So okay, so that means that these 2 guys are indeed connected to 31, just as I have written down here. And this other one of R4 is connected to R5. This should be connected to R5. One of the legs. Okay, the leftmost leg. So this is going down here, and R5 is here, and we've got a resistor in here. Actually, R5 is open. That's the one place where we need to add a resistor. These technical drawings that I'm making create something. I'll put it up on my website and I'll show it on this video, and then we'll make our modifications to this chip. Put some switches on it. I'm just wondering if I want to go ahead and test it in that configuration. But if I want to solder onto it, I'd rather just do it once. Maybe I'll just put some jumpers on there and test it with the jumpers, and then solder the jumpers onto a double pole switch. Anyway, let's get to the next step. Okay, so here I have a diagram of the GGLabs board, and I've marked all of the traces, all the pads that are important. The schematic that was provided on GGLabs was more of a block diagram and didn't have the details of the board layout actually. So anyway, after much tracing and a couple mistakes, I managed to find commonality where certain pins were joined up with other ones to make the building of a switch easier. So basically the way this is right now is like this. R7 is shorted, R6 is open, R4 is shorted, and R5 is open. And that's set up for a Release 6 Amiga 500 or newer, and also the Amiga 2000 motherboards that are 4.3 and newer. So basically the first thing that I have to do, this is without putting a switch in or anything, the basic thing is to cut a couple traces. You gotta cut the trace of R7, and then you got to cut the trace of R4, and then the next step is to add a resistor onto R5 and short R6. So we've cut the trace on R7, we've shorted R6, we've cut the trace on R4 and added a resistor between the two pins of R5. And that will make it work on an older Amiga motherboard. Now, that's not super useful to me. As I said, I want to use this on different revisions of motherboards, so I need to add a switch system to this. So basically, it was important for me to tone these out to do continuity tests on these so that I could come up with a game plan as far as putting a switch in. And this is the proposed switch. Actually, let me show you this one. So this switch will enable these jumpers to be shorted or open depending on whether it's a Release 5 or Release 6, and depending on the position of this switch. So it's pretty basic, but when you work on trying to get a double pole, double throw, double pole, double throw DP/DT switch, you have to find perhaps a common to switch between. So was my first job, to find a common pole between them, between the different opens and shorts that I needed to make. So as it turns out, A17 is common to the alternating short open situation of R7 and R6. A17 is here on R6, and it's connected also here to R7. So if you put that in the middle and you simply toggle between the two, you're toggling one of them open and one of them shorted, and vice versa. The same holds true for R4 and R5. The right pad of R4 is actually connected to the left pad of R5 internally in this board. So you just want to put that in the common position, the middle position, and simply connect the other sides of these to either side of it, and making sure to match it with the other side so that the Release 5, Release 6 is correct. Now I show here that the other trace, the other pad of R4 is not connected, and that's because it's already connected onto the switch with this wire on R6. So all I need to do in that case is simply run a jumper across the switch, and that creates another connection to pin 31. Also, interesting is this resistor. You know, when the switch is in the release 5 position, as an example of how to follow the flow, VCC goes through the resistor. The resistor is supposed to be between these two pads down here. So VCC goes through the resistor up here, and then it goes through this other wire down here, and then it goes to R5 left pad, so it connects right there, and therefore making the resistor between these two pads. And lastly, on this diagram, I thought I would indicate that GGLabs actually told me that the resistor could theoretically stay in place for both release 5 and release 6, you know, older and newer versions of these motherboards. So I modified this diagram one more time to indicate that the resistor is always shorted. There's always a resistor in position, and so there's no connection for the R5 on the switch. And this is actually the way I am going to try it, because I want to determine if that's true, that the resistor can stay in place. So I'm just going to solder the resistor straight to R5 and not connect R5 to the switch at all. Okay, so here we have the modified DiagROM with just some jumper wire on it, and we are going to see the result when I turn the power on. Okay, it looks good. And that's it. We're good to go. Okay, so here we have it configured the other way for my diagram on its wires. Let's just zoom in. And this is the release 6 motherboard again. And let's power it on and see what happens. And this again is with the resistor in place. GGLabs indicated to me that it could probably stay, but he's never tested it, and it seems to work with it in place. I don't think I'll button things up completely until I know that for sure, but it seems to be okay. Okay, so I've got all the wires connected. I've done all my testing. And here's a case I've created. Really, the only thing I needed it for pretty much was to mount a switch on, but perhaps the case is going to bulk up the ROM enough so that I could just grab it by the case and pull it out. It's going to give me a lot more leverage. Might make it more convenient for removing it carefully, maybe like with two fingers on each side like this and lifting up, or a wiggle back and forth or something. But anyway, so I'm going to put all this, first I'm going to solder the switch on and then test it with the switch. Okay, so I decided I would get a shot of this before I glue the rest of it together. And as you can see, we have a switch on the one side, switching back and forth. So had a bit of a problem getting something to fit. Basically what I needed to do is I needed to somehow grab underneath, you know, so that I could use this case to pull the chip out. The problem is not on the ends. The ends are fine. There's plenty of space here to run a lip underneath. The problem is on the sides. I wanted to run a lip all the way around, and the sides, manufacturing tolerances being what they are, one side had a lip and the other side really didn't. But it did have the gaps in between the pins. So what I did was you know, on one side I created like little pieces of plastic that go further in. Instead of one solid lip, it's little pieces of lip going all the way down between all the pins. It was a pain in the butt, and which is also why that if I made another one of these, no two would fit the same. So there's also a sort of an angle here as well for the actually the purposes of making this more of a surface area to glue to make this more secure, and also to actually have something to grab onto on the sides to pull. The ends, I think I've got enough anyway, but the sides, you know, so I'm hoping that'll work out. And other than that, I just need to maybe mark on the top, you know, I'm going to mark on the top what position the switch should be in, and also mark up here pin 1, you know, so I always put it in correctly. So yeah, see, that's the side where there's like no lip, and I created these little indentations so that there is a little bit of a space in between each clip to grab onto. So I created a little clip to go in there. Okay, so there it is with the cap on. I'm really going to have to glue the cap on there, otherwise this thing does, I mean, it takes a lot of force to push it on. The problem is when I push it on, I thought the problem would be pulling it off would be the issue.
And this is the final product. Thank you for watching.